Hello, good evening, viewers. Today I will explain little bit about heat transfer and some couple of problems related to conduction and convection. So in this video, as you can see, heat transfer is a subject we are dealing with. So in heat transfer, essentially there are three modes of heat transfer, that is conduction, convection and radiation. So which I will explain it, I have already explained in other videos regarding each of these modes of heat transfer. So that's how we'll discuss about some problems here related to conduction and convection. So initially I am going to deal with this problem. The problem here I have written, this problem is given in JNTU question paper. So the JNTU H question paper in the year 2016. So that is in heat transfer subject. So let's read the question first. A long cylindrical rod of radius 5 centimeters and K thermal conductivity 10 watts per meter Kelvin contains a radioactive material which generates heat uniformly within the cylinder at a constant rate of 3 lakh watts per meter cube. So that is the rate of heat generation, and the rod is cooled by convection from its cylindrical surface into ambient air at 50 degrees centigrade with heat transfer coefficient 60 watts per meter Kelvin. Calculate the temperature at the center and at the outer surface of the cylindrical rod. So this is the problem they have given. So let's put the problem in a diagrammatical format. So that is so as it is a cylindrical rod, so let's put the cylindrical rod like this. So this rod is diameter is given as some 5 centimeters. So obviously this is radius is given as 5 centimeters. So that is R is equal to 5 centimeter, and so as this rod is generating some Q heat, so that Q heat transfer rate is given as 3 lakh watts per meter cube. So that means for every unit of this volume of this cylinder, it is generating the radioactive material is generating about 3 lakh watts. That is the information which has been given. And also the thermal conductivity of this particular material K is given as 10 watts per meter degree Kelvin. So this is another information which is here available, and the ambient air is at about 50 degrees. So what is happening here is there is a cool air which is surrounding this particular rod. That air is having a coefficient of heat transfer, that is H. H of this particular air is given as 60 watts per meter degree Kelvin, and also the temperature of this ambient air, that is T ambient, is given as 50 degrees centigrade. So this is the information given. So we can write down these things here. So that is what is the ambient temperature, that is T infinity, is given as 50 degrees centigrade, and Q, the rate of heat transfer, is given as 3 lakh watts per meter cube, and the radius of this particular cylindrical rod is given as 5 centimeters, that is 0.05 meters. Then we have H, that is the heat transfer coefficient of the ambient air, the cool air, which is surrounding the cylindrical surface, is given as 60 watts per meter degree Kelvin. And also the thermal conductivity of this particular cylindrical material is K. Thermal conductivity is given as 10 watts per meter degree Kelvin. So this is the information given, and we have to find number one. First is we have to calculate the temperature at the center of this particular rod. So that is temperature at center. So that is T0. So we can indicate that as a T0, which is a temperature at the mid plane. We can call it as mid plane also. So that is the temperature we have to find out. And second is we have to find the temperature at the outer surface. The temperature at the outer surface, that is TW. We can call it as wall temperature also. So we need to calculate the outside temperature, which is TW. We have to find out this. So in order to find these things, we have to look at the heat transfer table. So if you go to the heat transfer table, that is on page number 48. So that is, our problem is falling under the category of steady state conduction with heat generation, because there is there is no sudden cooling or something like that. So it is a uniform cooling. So it is a steady state conduction with, of course, there is a heat generation is also happening. They have given because of the radioactive material. So that is why we have landed up in this particular page. We can look at the index page also, index, and come to this. So we have to see this problem as a steady state conduction. So in the conduction, steady state with heat generation. So here you can go to page number 48, steady state with heat generation. So if I go to 48, page number 48, so here this type of problem has been the formulas have been given. So in this, if you see, this is the solid cylinder. The solid cylinder, it has the ambient temperature. Here is the ambient temperature with certain heat transfer coefficient H, and there is some radius, and you can find out at any given radius what is the temperature. You can find out, that is a TR. Of course, they have not asked this in the problem. What they asked is find out the temperature at the wall, that is the surface, that is TW. We have to find out the TW, and also we have to find the temperature at the center, that is T0, that is mid plane temperature. So this particular line indicates the mid plane temperature. So these two things we have to find out. First, let us find out the outside temperature, because if you want to, there are two formulas which we have to use in this problem to solve this problem. First one is T0 is TO or T0, which is mid plane temperature. T0 is equal to TW plus QR square divided by 4K. But here, in order to calculate this T0, first we need to know the TW. Remaining all information is available. Q is available, R is available, K is also available. Only thing is we don't know what is the TW, that is the surface temperature, the wall temperature. So in order to find that, we have to use this particular formula, that is for outside convection. We have to use this formula, that TW is equal to T ambient plus QR by 2H. So in order to find, first let us find the TW. So what is TW? TW is equal to we can write from heat transfer table, okay, heat transfer table, okay, for steady state, okay, steady state conduction with heat generation. So this is the way you have to put it. From this particular information, I have TW, that is outside temperature, outside surface temperature on the cylinder. So that is the first thing we are going to calculate. So this is indicated by TW. This is indicated by TW. So here the formula is TW is equal to, you have this formula, TW is equal to T ambient plus QR divided by 2H. So if you take if you substitute these values, T ambient is given as 50 degrees plus Q, that is the rate of heat transfer, is given as 3 lakh watts per meter cube, and then what is the radius given as? R is given as 0.05 meters divided by 2 into H is given as 60. So if you calculate this thing with the calculator, so you are going to get about so 3 lakh into 0.05 divided by 120, so that is 125. So which is coming to 3 into so basically this is not 3 lakh, this is 3, actually 3 it is given as 3 watts only. You can take it as 3 watts, not 3 lakh actually. So if you take this 3 into 0.05 divided by 120, this is coming to 1.25 into 3 lakh, exactly this is 3 lakh only. So 3 lakh, so you are getting about 1.25. so that plus 50, you will get it as about 51.25 degrees. So this is the temperature of the wall. Now after the once you find out this temperature of the wall, now second step is find the outer this is the mid plane temperature. So we have to calculate the mid plane temperature. So for mid plane temperature, the symbol is T naught. The T naught is equal to there is a formula here, we can see the T naught is equal to TW plus QR square by 4K. So if you take this TW plus QR square divided by 4K, so if you substitute these things, so TW is coming as 51.25 plus 3 into 0.05 whole square, 3 lakh, this is 3 lakh into 0.05 whole square divided by 4 into 10. 10 is the, this is the thermal conductivity is 10, Q is 3 lakh, R is 0.05. So if you substitute all these things, you will get as 0.05. If you calculate this 0.05 into 0.05, that into 3 lakh, this divided by 40. So you will get about 18.75. This particular portion is coming 18.75, that plus 51.25. So you will get 70 degrees. So this is the mid plane temperature. So T0 is 70 degrees centigrade. So therefore this is the mid plane temperature. You can calculate using this formula. So here both the things we have calculated. The temperature at the center, which is coming to about 70 degrees centigrade, temperature at the outer surface of the cylindrical rod, that is 51.25. so this is the way you can calculate the temperatures for a steady state conduction with heat generation type of problem. Thank you.